welcome everybody. Just really appreciate it. This actually got a lot of interest, a lot of different folks doing different things with rigging, so that's awesome. Real quick disclaimer: this event's not affiliated or endorsed by, if I could talk, affiliated or endorsed by any federal agency, and is not legal advice or safety advice, although this guy has a lot of experience in the safety world, and your participation and your engagement is not an indication or endorsement to purchase from anybody. We do love participation. We love it, love it, love it. We have some of the folks. Here we go, Patrick. You ready for this? Mustafa from NIST. Address real life situations. That's what you're going to do, right? We're going to talk about real life situations. James from MPS. This is the best briefing ever if. From MPS, attachment point capacity is covered. We'll talk a little bit about that, right? And Daniel from FWS, he doesn't fall asleep. Daniel, are you here? He might not even have made it in yet. Well, we have the Zoom shock treatment just in case when Daniel gets here. We'll hit the button so he doesn't fall asleep. Jonathan, if it helps to avoid an accident in the field, absolutely, right? That's what we're talking about, right, Patrick?
Yes.
Bruce from FAA, it saves me from dying. Love that one. Laszlo from NIST, addresses training and qualification requirement for riggers. Love that. In fact, we want to remove some of that training requirement and down at the field, I think. Kavana, cool name, from the VA. I can take what I learned and apply it directly to the field. Hopefully that is true today. Fantastic. So please address this. John from NRC, what is a self-centering shackle technology? Well, that's a softball. You ready for that one? You ready for that one, Patrick?
Yeah, absolutely. It's a special design that I developed and patented, and it automatically centers the wire rope in the center of the pin because there's a slight depression in the center of the pin. You'll see it. I think we have some photographs later.
Oh, yeah.
You'll see the shape of the pin is such that that's what the patent is all about. And the idea is that one side of the shackle is bigger than the other. A normal shackle has an equal size hole on either side. One side is threaded, the other is just a pass-through. Well, with mine, we made one side much bigger, so it allows us to center the load on the pin. Love it.
And David from FDA, balance and minimizing swing on load suspended from a crane. I do believe that we're going to be talking about that. Master rigger right here, going to be talking about that. Brian from USBR, discussion, inspection, and training requirements for rigging. Love that. Laura and Shane, most common mistakes and how to prevent them. Love that from the VA, both from the VA. William, NPS, what are the PPE harness requirements for a project inspector to go up on a roof, man, lift, swing stage, scaffold, or ladder? That is not what we're talking about today, William. So if you're actually here, we're not talking about PPE harnesses. We're talking about crane lifting and rigging from a crane. Mustafa from NIST, inspection and training requirements for rigging. There you go. We'll absolutely get into that, each one of those. So we know that we have some session docs here for you. It includes the presentation, also includes some of the reference materials that we're going to be covering today. And now, so we have maximum participation, we're going to be asking, why did you decide to join here today? I'm interested in rigging safety. I want to make sure that I have the latest information on rigging. I run projects that use rigging, or my boss made me come. And then if you're aware of any, have you ever heard of requirements for loads, centering loads on shackle pins? So we'll be talking about that today as we get going. So tell us a little bit about TPH. I know that you guys are in Manhattan. You have some really cool equipment. You are a master rigger. We'll get into that in a minute. But tell us a little bit about TPH.
Well, the company was set up in 2008. We had a previous company, but 2008 we set up TPH. We erect tower cranes in New York City. I'm a licensed master rigger. We do major rigging jobs. I put the retractable roof on the Arthur Ashe Stadium in Queens. That was an interesting job.
I imagine so.
And we're a full service rigging company. I've designed cranes and got them built overseas, which we use specialized cranes. You can see on the screen, there's one of them working in Lower Manhattan, bringing some HVAC equipment onto a roof. The crane comes apart. It goes up onto the roof. It goes together. It's an electrically powered crane. So in the situation, that particular job was on Pearl Street in Lower Manhattan. We could find a crane that had enough reach. It was about 425 feet. But the problem was the intersection that the crane needed to set up on. The intersection was too tight for the crane to set up. So, and it couldn't travel on the street once it was, so, once we had it assembled with the counterweight. So we were really the only game in town.
That's wild.
Yeah.
And is that the Hercules crane? Is that what you're talking about?
That's the Hercules crane. That's the Hercules RK22.
Very neat.
Yeah, it's a fantastic machine. It lifts 6,000 pounds out to about 20 feet. Then the chart starts dropping off a little as you get further out because of leverage.
And you also created patented shackle technology. That's what you're seeing there with the self-centering shackle. And you are a woman-owned small business. Awesome. And you guys do a lot of work in New York as well. So yes, today we're going to be talking about, I'll get you introduced to Patrick here. We're talking about rigging safety standards because there's a lot of question about that, as well as the importance of symmetrical load. That's what we're talking about. Symmetrical load management, and talking about multiple points of failure. And you're going to find that those points of failure are usually what we call picnic, between the problem in the chair, right? Or between the ears, right? So we'll talk about some case studies that you have for us today, right, Patrick?
Yep.
And then talking about manufacturing to the proper standards. I'm going to end this poll in another 5, 4, 3, 2. Any of the wallflowers that want to participate, go ahead. 1, and yeah, we did get one last one. There we go. So here's what we got, Patrick. As I'm introduce you, 71% interested in the rigging safety. I want to be sure that I have the latest information. 41% and 12% run rigging projects. And we love the fact that you've been here before. If anybody's been here before, that's great. And there's 53% are aware that you have to center. That's good news, because I think the last time we did that, most people did not know. And been to a GovBrief session. We appreciate you guys joining us back. So Patrick, you do a lot of work with different organizations as an expert witness, because they call you in when there's been an accident, right? That's usually when you get called in.
Yes. And
the whole reason why you're here is to help understand how you can mitigate a lot of the problems that you have in rigging, right? And because you're a certified hoist operator, what does that mean? We saw the big cranes. How does that?
Well, I have an an unlimited license to operate cranes. I'm also a licensed master rigger, which means I can erect those tower cranes that climb up with the building. I'm licensed to do major rigging jobs. I'm also a certified welding inspector, so I'm sort of all about that business. That's where my qualifications are.
And you do a lot of work. Now, when you're in front of and you're in a courtroom, right? Because a lot of times you're pulled in as an expert witness. What are some of the things that you've seen that create the biggest problems?
What I see as the biggest problems is that people abandon safe practice. Like, the theory is great. They say, okay, we have a plan, we have a rigging plan, we have a dismantling plan. But then you'll get somebody in middle management says, we don't have time for that. Let's just cut this out. Let's do this. Let's do that. Classic case was I was a master rigger on Columbia Science Center in Harlem, and they were doing a demolition. Now, the problem with demolition work, if I'm lifting something with a crane, and if it's too heavy for the crane at that particular configuration, the amount of boom I have out, the radius I'm at, there's an LMI, a load moment indicator, and that tells me, no can do, too heavy, problem. But now, in demolition, like for instance, I took down a bridge between two buildings. It was up about 150 feet between two buildings in Manhattan, between Madison Avenue and Park Avenue on East 24th Street. When you pick that, your LMI is no good to you, because you're not picking it from the ground. You try to lift it, you cut it loose and it's too heavy, you're flipping the crane over. So it's really.
And you've seen that happen, haven't you?
I've seen accidents there up at Columbia Signs. So the sort of rule in demolition is make the thing as light as possible before you pick it to lower it. Now they were doing this up at Columbia Science Center. They had to demolish 2 buildings. There were beams that were encased in concrete. Now, good safe practice is remove the concrete before you try to take the beam. But again, some hot shot was like, no, we have the capacity in the crane. I've done the calculation. Well, we can do it. So they cut the beam on one end. They cut it at the other end. But what they didn't realize is that the beam didn't end at the wall. It went through the wall and it cantilevered on the other side and picked up another beam. So when they cut the one on one side, the one on the other side collapsed and killed the guy.
Oh my gosh.
So I said to them, guys, so when you abandon sort of basic rules of rigging safety, if you had taken the concrete off the beam, you'd have seen that there was a connection about 6 feet in from one end. But you didn't do that. So you don't know what you don't know. So it was a tragic end to a very stupid move. But yeah, in order to remove the concrete, you have to get a guy in a man basket. He goes up there with a chip and hammer. It takes him a couple of days to get the concrete off. But if you can take it down in one piece and then just cut it in the center and throw it in a dumpster, concrete and all, yeah, it saves time, but at the cost of like abandoning safe practice. Everywhere we see in contract documents, it says best practice, best practice, best practice. If you know something is the right way to do it. And I find that decisions that are made in the field lead to accidents. Decisions that are made at the design stage don't lead to accidents. And there's some famous crane accidents. Big Blue was in Milwaukee. They were putting the roof on a stadium. And the guy decided to take a shot. The wind was too high. An experienced operator said, I'm not touching this, goodbye. And some young guy who just got exactly, oh, I'll do it. He wanted to be a hero. Killed 3 people. And, you know, a friend of mine was putting the antenna on the Freedom Tower in Lower Manhattan, on the rebuilt Freedom Tower. And he got injured. A bolt fell from the top. An ironworker let a bolt drop a few hundred feet. He was on the 103rd floor when they were putting the antenna. It hit his shoulder and then bounced and hit a lady from the Port Authority. And I said, he's a licensed master. I said, Tony, what were you doing on the 103rd floor underneath the antenna? Oh, he said it was a big event. The cameras were there. There was news stations there. There were cameras in the tower cranes. And I said to him, you know, yeah, it might have been a big event, but the basic rules of gravity don't stand under a suspended load. You abandoned all that because you were pressurized by the suits and the media. I would have said, get the hell off the floor. Yeah, absolutely.
So as you mentioned, a lot of this happens in the field, and
Yes.
having a good design all breaks down if people don't follow it in the field, right?
Exactly.
So what's your role in rigging? Do you engineer and specify? Do you do the design work? Or do you purchase? Are you a safety manager, rigging supervisor, rigging signal person, or other? Let us know where you are, and we're going to get right into some of the manufacturing standards as well as performance standards in this, so that you can walk them right down the path of how they can pay attention to what's happening in the field, best practices, do those best practices, and make sure that it doesn't get, as you said, it could be middle management. They come in, it could be the media thing, it could be, hey, there's you have exposure and things like that, but making sure that your rigging standards trump all those things and safety trump those things. And I love where you're headed with the human factor, all right down at the level. So as everybody's finishing this poll, let's talk about the rigging safety standards, because you can see what's right and what's wrong, and tell us why this is.
Well, let's go back to when shackles are designed. They have to have a 5-to-1 safety factor. In other words, it should be able to withstand 5 times the load, or the safe working limit, the safe working load limit. It can be written WLL working load limit or SWL safe working load. It's stamped on the shackle. So let's say a shackle that has a safe working load of 5 tons, it has to be tested at 25 tons. In other words, they put it in a machine and they physically try to pull it apart. And it mustn't fail under 25 tons. So there's a safety factor. Here's the problem. When the shackle is put into the test machine is the part that the pin goes through is about the same as the space between the two sides of the shackle. So therefore, when they apply that 25-ton load, there's 12.5 tons going to each side, what we call the shear plane. So you got 12.5 tons applied to the left, 12.5 tons applied to the right, evenly applied. But now you get out in the field. So when they test and they say, okay, we put a load of 25,000 pounds, it's good. It resisted that load. It failed at 26 tons. Okay, that means that it was the failure was 13 tons on either shear plane on either side of the pin. But here's the problem. When you get in the field, you're not evenly distributing the load. The shackle tends to ride to one side or the other. So on the right-hand side, where we say it's wrong, we have to resist that tendency, because now you can see that we're not loading the shackle in the way it was loaded in the test bed. We're putting, maybe, I figured 75% of the load is going to one side and only 25% on the other. But in the test, 50% went to either side.
So when we talk about symmetrical, this is what we want to do, right? And there's ways, like in figure 3 right there, that's your self, it's not self-centering, but at least it's centered, right?
It's centered. This is what engineers generally specify in their drawings. They'll tell you, make sure that you apply the load to the center of the pin. And you can do that in a couple of ways. One way is to pack washers on either side. That's fine. That's perfectly acceptable. There's another way is to slide a spool. I actually have a video that shows this. Crosby, who are a market leader in shackle manufacturing design, they make a spool that slides over the pin, and it's got a depression in the center. There you go. There's the on the bottom left. There's the spool, and on the bottom right is washers. So you can slide a spool over the pin, but there's still a problem with that spool because it's a loose part. And for people who are practical people out in the field, when you're rigging, you don't want loose parts because they fall, they drop. If you're up on a height, let's say you're erecting steel and you have to undo a shackle, now you need 3 hands. You need one hand to hold the bow of the shackle. You need another hand to unscrew the pin. And what about the spool in the middle? That's going to fall out. Now it falls out. What do? You stop the job and go looking for it? I don't think so.
And this is where you get into the points of failure, right? So if
correct,
and this is down at the point where you have the worker, and his or her job is to get that thing connected as quickly as possible so that it can be lifted, right?
That's where the pressure comes in. Go, go, go. We're not slowing down for anything. We have to go. We have this figured out. We need 3 picks an hour, 4 picks an hour. There's no time for screwing around with washers, spools, loose things that could fall, that have to be inserted or installed. With my shackle, it's one piece. It's idiot proof. What was that thing with the insurance company? Even a caveman could use it. Yeah, that's it. Even a caveman could use my shackle because there's nothing to add. You take the pin out, you put the pin back in.
Mm-hmm.
You're not screwing around with washers or spools or anything.
And I think what you have here is there's no on-site oversight by the design engineer. How often do you have engineers there and designers there that are specifying down at the place where the guy with the gloves is putting stuff together, right? There's never anybody down there.
Never. The engineer, the design might be perfect, the specifications might be perfect, but if the caveman in the field, if he doesn't follow the specific protocol that's outlined, which is you have to get a spool, make sure it's sized for the right size of pin because it's different sizes of shackles. If he doesn't do it, then all the design effort is wasted. because you haven't made it idiot proof. The guy's going to go for the path of least resistance. He drops something, it falls. Oh, well, forget about it. Let's go. So that's the problem, and I've seen that in the field. I started my apprenticeship 50 years ago this year.
50 years ago. What were you, 4 years old?
1974, in Ireland, in Cork.
In Cork. I'm going there in October.
Great.
I'm going there.
Also, on our shackle, you have a QR code on the end of the pin. So if you guys have a camera, if you can see the QR code, just read that QR code. That's the inspection report. When we do batches of 2,000, we send them for testing to a company called Modern Industries in Erie, Pennsylvania.
It does work too. The QR code does work. It calls up, calls this up.
Yeah.
Yeah.
It tells you exactly what at what point it failed, whether it failed, and we manufacture and test to a military spec, so it's way above what's needed by ASME B 30.26. This is the RR, I think RR-137.
And here you see on the left-hand side, you can see where there's a failure. Also, you have the problem with what's happening with the strand, right? The cable strand.
Exactly. When you have, if you look at our shackle on the right-hand side, the depression in the center is designed to be equal to the size of the sling that has the same capacity as the shackle. In other words, if that's a 3/4 shackle, yeah, that arrow right there. If that's, let's say that's a 3/4 inch shackle. That's our 3/4 inch shackle. I think is good for. Let's say it's good for 10 ton. Well, this a 1 inch wire rope is good for 9.8 ton in a straight pull. So the radius or the diameter of that depression, the radius of the depression is a 1/2 inch. So a 1 inch wire rope just fits nice and snugly in the center, and it prevents the flattening that you get on wire ropes, which causes these strands to come apart, and your wire rope is gone. It's useless. You throw it in the dumpster. So we protect the wire rope as well. So that's the second feature of the design.
That's awesome. And I love this. So the biggest point of failure is human error, right? And you mentioned this either because you mentioned the media, you mentioned just time, right? In this instance, you're eliminating all of the other parts, right? You have removing the human error, and no offense, the people that are down working on the or in the shipyard or wherever they are when they're creating and using the shackle, their job is to get that thing connected and get it moving. And you want to be able to do that as quickly as possible without any problem.
And because of that taper that I designed, the taper just at the base of the threads, it does two things. It moves the shear plane, the failure shear plane, and we want the failure to occur at the pin. It moves it in, so it gives you a greater, so you have a little bit of bearing on that tapered surface, as well as the shear force. You have a little bit of bearing help there. And also there are less threads, so now it's faster to engage and disengage it. And by putting the taper in there, it increased the capacity by about, I think, 24%. So it's 24% stronger by having that taper rather than just having a square edge. So you pick up 24% and you have less thread.
So what I love about this is it makes it, like you said, it brings the design engineer right down to the end user. They don't have to worry about your washers or any additional equipment. And isn't, like it says right here, impossible to mismatch or lose the components. If you lose a component, you lost either the U part of the shackle or the pin. You can't use either one.
Exactly.
And I think this QR code thing is really cool. So when the person that's there can just snap that with their phone and they can see what is the rating of that.
Yeah, well, the rating is stamped on the shackle, but they can test to see. Yeah, if you take a look on the picture here, if you imagine, and this is a real life situation, a crane operator, a friend of mine who's a crane operator in New York City, he snapped this picture from the cab of the tower crane. Now, the load that's on there, that's 17,600, is called a balance weight. And the purpose of the balance weight, when we're climbing a tower crane, I'm sure you've seen, and a lot of people wonder, how does that crane climb up with the building? Well, what happens is, first of all, you have counterweights at the back, which compensate for the weight that you're lifting. So you have to balance. If the boom is up in the air at a very high angle, your load moment is backwards. The crane wants to fall over backwards. So you have to lay down the boom until you get to a point where the load equals the counterweight. So now you have no moment forces on the climbing frame. There's a climbing frame that goes around the top of the crane. If you look at a tower crane, typically one that's going to climb, and you look up under the cab, you'll see a wider section. That's the climbing frame. And in order to climb the crane, it's a hydraulic system. There's a hydraulic cylinder. So you balance the crane. So now you can lift it without a problem. But in order to balance it, you got to put a weight on the crane. And typically the operator will know from either from the engineer drawings or from his own practice. He'd say, okay, I know that if I boom down to an 82-foot radius with a 17,600 pound weight, that balances me. So now if you take a look at the shackle on top, the weight is all the way to the left. Now let's say that that's a 10-ton shackle. So when that was tested, it was tested to 50 tons. So that was 25 tons to each side. But now you're putting 75% of the weight to one side. The guy in the field is going to say, oh, that's okay. It's a 10-ton shackle, 17,600 load, 10 tons is 20,000 pounds. We're good. No, you're not good because you're working inside a safety factor. You should have tested this to 75,000 pounds, not 50,000 pounds, because you're now within the 5-to-1. You're now down to about 3-to-1. So it's still okay. But if there is an accident which is sort of tangentially related to the rigging, and they start looking at everything, they'll say, oh, did you not realize that you were violating the safety standard of 5-to-1 safety? That's a big problem. That's a big violation. And
you also, what I find amazing with this is the crane operator has no idea that it's not right until it's, what is that, about 20 stories high on this?
Absolutely. A guy said to me one time, I was operating a tower crane. He said, can you make sure that the riggers use the correct size chokers, that we call them chokers or wire ropes or slings? And I said to mister, the first time I see that load is when it's coming over the edge of the building, 25 floors up. I'm sitting like a bird up in my crane. You got to talk to the guys in the street.
Yeah.
And
this is a close up of this, so you can see where you can start to run into some problems. So you mentioned this, and this has your self-centering pin, right? And it's a single unit, and has that taper you were mentioning before. There's no additional parts or anything else. And this is one of the things that I think is really cool, is that you're solving a problem based right down in the field, where you never have to think about it again.
Exactly. There's no post-production work after the design where there's an assembly required every time. They have to do it every time. They have to assemble this. They put a sleeve over the pin. They put washers in it. It doesn't happen. This is where design flawlessly meets execution, because once you supply them with this, it's not possible. And there are some very creative people, working in construction that can find a way to screw anything up. But I would defy them to find a way to screw this up. I think I can't imagine. And I've been witness to some major screw ups from sitting in the cab of a crane watching what's going on. But I can't see a way. We're going to have some fun in the field and do some videos. and get some feedback from some of the major crane companies. I have some of my friends who are design engineers, they've looked at it and they love it. They said, that's great. We're going to specify that in our drawings, so they have to use your shackle. The idea that we'll tell them to center the load on the pin by either putting washers or a spool over it. It's okay, great, we told them, but who's policing them? Who's making sure? This is best practice in the rigging industry, is to use these shackles.
There you go. And as you mentioned, it's third-party testing, it's third-party certified. You can see that on the, like, just right there on each shackle, you can see how they're tested out. Now, what do you mean by 3 samples?
Well, normally we take 3 samples of for when we do a batch of 2,000. 2,000 is sort of the optimum number because that's a day's production in the forge. Because anything less, they're going to say, well, we have to break that. We have to change the dies out now for the next item. They prefer to do that at night, so that they don't have the guy standing around. So that's the sort of the sweet spot is 2,000. So out of 2,000, we take 3 samples, we send them to the testing lab, and if they're all pretty similar, we do the QR code and attach it to the pins for each of the shackles from that batch. So the next batch will be a different QR code and a different inspection, hopefully the same result. The load tested at 2.2 times the load, that's the service load. That's the first part of the test. And you'll see if you read the QR code, when you apply a load 2.2 times the rated capacity, in our case, say 5 tons, 2.2 times would be 12.5 tons. Now you have to apply a 12.5 ton load, and the pin has to, once you take the load off it, the pin has to be easily removed by hand after the first turn. So that's the first part of the test. The second part of the test is the ultimate destruction. You just keep on pulling until the thing comes apart. And that has to be the 5 tons. That's up to a capacity of 150 tons. Over 150 tons, it's a 4 times capacity. But under ASME B 30.26, it's 5 times capacity. So that's the 2 tests you have to do. And if we find a problem, then the whole batch, we have to go back then and we test, I think we test 10. If there's a problem with one of the 3, then we'll test 10. If one of them comes up at less. But generally, we've been running into about 6 to 1. I haven't come across a case where we've been below the allowable factor.
That's awesome. And you're looking at places to manufacture. This is something if you're actually purchasing it from the government, if the government is buying it, it has to be done in the United States or
yes,
compliant.
There's a publicly traded company called Wabco in Warren, Ohio. They're good guys. They've been in the forge. They used to make brake components for locomotives. I think it's owned by, I think it's Westinghouse owns it. It's publicly traded, and they do a fantastic job. So, what's better than made in Ohio?
That's awesome. So, key takeaways, best practice, removing it from the field, the human element that you talked about. And I just imagine, right now it's hot, right? So it's not a big deal. But in the middle of winter, when you're moving things, you got gloves on, the shackle's frozen or freezing, and you're trying to get washers on. And you mentioned this earlier about just being there on the dock and not being able to find the washers or enough washers, and the next thing you know, you're not working best practices, right?
Yeah, well, I teach classes in New York City. If you have a crane operator license in New York City, in order to renew your license, which is every 3 years, you have to do an 8-hour refresher course. I teach that course. Because I'm an OSHA authorized trainer, and also I'm approved by New York City. I also teach the Master Rigger renewal, 8-hour refresher again. And what I do is I actually give guys samples of my shackle. They love them. The guys in the field love them. They're like, how come we had to wait for an immigrant from Ireland to come up with this? How come nobody thought about this before? I'm like, what can I tell you?
What can you tell? You're
My
absolutely
my
right.
my family have been in the forging business for that's metal forging, not forging checks. My father was a
Yeah.
blacksmith. He served his apprenticeship with his uncle, who was a blacksmith. I was in that forge. He showed me the tools my father started. He said, "Your father came here when he was 14 years old. These are the tools that he learned his trade on." I said, "The actual, he said, yep, that's the tongs he picked up. That's the hammer. That's the amazing."
That is wild.
His father. Um, there was a theory that the Tarrant family came to Ireland with Cromwell's army as armourers, and they had the guild around. Like my uncle was a coach builder. We had a harness maker in the family. All of the trades around the horse, blacksmithing, farrier. So Cromwell was not well received in Ireland. So we had somebody research it. And I said, we think that your family came to Ireland as armourers and blacksmiths with Cromwell's army. That's enough research. Thanks very much.
That's wild. Hey, speaking of, you mentioned in the field, I mean, the people love them and for samples and you can all get free samples, right? You'll send them out
Absolutely.
to them. So if you'd like to get if you like super shackles samples, you can get those. You want to discuss this current rigging requirement or discuss a BPA for purchasing in your agency, we could do that. If you're procurement or something else, please contact me. I appreciate you sharing all the things that you have, Patrick. Included in this, you'll get a video recording. The links will come to you, everybody that was registered. The session docs that you can also download, I'll pop them in here as well, which includes the presentation itself, as well as, and you can reach out to Patrick and schedule some one-on-one meetings. But it'll be 8 different samples, right? 2 of each.
Well, the first lot that we have coming, the next lot that's coming in shortly is a 3/4, which is a 10-ton. So
Okay.
we'll send a couple of those out. I think it's better to send 2 because nobody uses one shackle. It's always pairs. So
All
try them, give them to guys in the field. If they don't like them, you have a free paperweight, and if they do, order some.
So, all right, fantastic. Well, we appreciate you joining us, Patrick.
Now, if anybody has any questions on this session, they should I can address any queries.
I appreciate that. Any questions before we jump off? Want to make sure that you have that. Get some feedback here. Anybody want to pop open and ask some questions to Patrick? If you have anything, if you have a current rigging requirement or anything that you need, you can pop open. And let me see what we got here. Otherwise, we'll get you guys out of here. Fantastic. Well, I appreciate it, Patrick. Thank you very much for joining us and for bringing us up to speed. Congratulations on the patent, and that's a pretty cool thing.
Terrific. Thank you so much.
All right, appreciate you guys. Thanks, guys.